All right, my name is Teria Dankwa Samuel. Now today we are going to look at a topic called functions. Now if this is the first time you are watching my video, just subscribe in order not to miss the next videos. Now let's proceed with today's topic, that is functions. Now, any relation between the elements of the domain and the codomain such that each member of the domain is related to one and only one member of the codomain, that is functions. So the first set and the second set. Alright, so let's say this one is x and this one is y. So the members here are called the domain. Yeah, and the members here are also called codomain. So each member of the domain has only one member in the codomain. So 1 to 1. So this one is called function. Very simple. Alright, so always this one domain, this one is codomain. That is the first, then the second. First set is the domain, second set codomain. Alright, now let's move on. So we are going to proceed with what I said. So we have a domain, that is the first set. So if you are asked to list the domain, you straight away the domain, that is D. Our domain, we have V, R, and C. So that is our domain. Now our codomain, so our codomain is 2, 1, then 0. Very simple. Now let's proceed. Now we are going to look at the difference between relations and functions. Now, not all relations are functions, but all functions are relations. So for instance, the first one, this one is a relation at the same time function, because by the definition we said each element or each member in the domain should have an image, or each element in the domain should have each member in the codomain. So each element in the domain corresponds to only one member in the codomain. So this one is a relation at the same time function. Now the next one, now this one is a relation but not a function, because by the definition the C should have a member here, but the C is not having anything there, so it's easy to be a function even though it's a relation. That's nicely done. Now this one, that is our third example. This one is a relation but not a function, because R, which belongs to X, is taking 2 elements here. By definition, R is supposed to take only one member in the second set. So here the case R is taking 2. It's easy to be a function even though it's a relation. Yeah. Alright. So this one is a function because each member in the domain, that is the first set, is having only one member in the second set, that is one image in the second subset. All right, now let's talk about the range and then the images. Now to find the range, always move to the codomain, because the range is a subset of the codomain. Now let's check this elements here. The codomain here have 1, 2, 3, 4 up to 6. So they are the codomain. Now to know the range are the images here, the images. So that is 2, 3, 4 and 5. So the range is a subset of the codomain. So you have 2, 3, 4, 5. That is that. So the images are same as this one. That's the range. So this one is the same as this. So if I ask to write down the images, it's just the same as the range. Alright, so always check the codomain. The images there, those that are marked, the arrows, they are the range, and they are the images as well. So don't forget. So we have 2, 3, 4, 5. Now this one, even though it's a codomain, but it's not part of the range, and this one too, that's that. Now let's move on. Now one-to-one function. Now for a function to one-to-one, f of a must be equal to f of b. So we say a equals b, so a equals b. So we call this one one-to-one functions. So let's solve examples. Yeah, so this one is a typical one-to-one function. Each member in domain has only one image, so one-to-one. Alright, so let's solve examples. Now the first one, we have showed that the function defined by this one-to-one. So first of all, let's state our condition. For a function to be one-to-one, f of a must be equal to f of b. Good. Now, so we are going to replace this one with x on our left hand side, then we do same to our right hand side with b. So we are going to put a into this. So where we see s, we put a there. So we have s plus 2, so I'll replace s with a. So a plus 2 plus, now we have b here, so we are going to replace s with b. So b plus 2. Okay, now let's move on. Now I can send this one to this side by subtracting 2 on both sides, so plus 2. Let me pick different color. So minus 2 cos b plus 2 minus 2. Now this one cancel this one to cancel this. So we are left with A equals B. Per the condition, it said for a function to be 1 to 1, A must be equal to B. Therefore, this one is 1 to 1 function. Very, very simple. Now let's proceed with our next examples. Okay, so in the example 2, so we have this one, f of x. This time we have 1 on x plus 3. So same thing, f of A must be equal to f of B. So straight away I will put A in this on my left, so 1 over A plus 3 equals 1 over B plus 3. So we can do cross multiplication. Yeah, we can do cross multiplication here. So 1 times A plus 3, we got the same thing, A plus 3. Then this one, this side is this, the other side to B plus 3. Good. So we can send 3 to the other side just as I did. So I can send 3 to this side. So this one is the same as A plus B plus 3 minus 3. So this one is same as subtracting 3 on both sides. Cancel this. So A equals to B. So this one is a 1 to 1 function. Alright. So let's move on to our last example. So we have g of x equals x squared plus 1 over 2. So we are going to show whether this one is 1 to 1. So per the condition, so g of A must be equal to g of B. Alright, so on my left I'm going to replace S with A. So this is A, so I'll put the A here. So I'll have A squared plus 1 on 2. Then on my right, B, so B plus 1 over 2. So same thing, we can do cross multiplication. So cross multiplication, let me pick different color. Alright, so the 2 will multiply this one, A squared plus 1 and then 2 B plus 1. So we can divide through by the 2. So we can say over 2. Over 2. So this one will cancel this. And this one will cancel that. Now you can also expand, you get the same thing. So we have A squared plus 1, then B squared plus 1. So we know this one will cancel this one straight away. For the two examples that we've done. So a squared b squared. So let's find a. Let's see. So to find a, you have to take root on both sides. So this one will cancel this, put everything here, and this one also cancel this. So we're going to have plus or minus b. So because of this one, it ceases to be 1 to 1. Yeah, unless a condition has been given a question that, or unless a condition has been given, this one ceases to be a function, that is 1 to 1 function. Okay, so in our next video we are going to look at onto functions, and also we are going to talk about the function notation as well as the inverse of a function. So subscribe for more videos. Thank you very much.